Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math YouTube channel. Make sure you like this video. Go ahead, hit that thumbs up. Make sure you drop a comment down below, especially if you have questions about anything that I attempt to explain. Drop your questions in the comment section. Also, share this video with somebody. All right, now let's get started. Now, what are we doing today? Today, we are solving a quadratic equation. We're solving a quadratic equation. All right. We're solving, and this is the equation. X squared minus 10x plus 25 is equal to 0. What does that mean? That means I'm figuring out what numerical value of x is going to make this a true statement, meaning it's going to make the number, the numerical value or result in the left side of the equation, the left side of the equal sign, equal to 0. I'm going to figure out what number that is. All right. This is how we problem solve. We practice in problem solving. That's what algebra is for. I mean, not only that, but I mean, developing your math skills will qualify you for a job or a career or some type of entrepreneurial pursuit in the STEM field, in the STEM area, science, technology, engineering, mathematics, as well as business. My background is actually in business. My degree is in finance, right? And I was able to understand a lot of the concepts in finance 20, 25 years ago when I was an undergrad because I was very strong in algebra. And we use a lot of algebra in a lot of our coursework: financial management, international financial management, commercial bank management, all that, real estate, risk management, all of that. But anyway, this is about problem solving, right? Human beings need to learn how to problem solve, need to know how to problem solve and use critical thinking ability. And math can help to develop that skill. So whenever you're thinking, well, I got to learn this, what's the point of knowing this? That's why, to develop problem solving ability. And if you think you don't need to have problem solving skills, you're sadly mistaken. All right. But also keep in mind, there are a lot of people that don't want you to have problem solving skills because that way they can keep taking advantage of you and keep exploiting you and exploiting you and exploiting you. But, if that's what you want, hey. But anyway, for those of y'all that don't want to be exploited and do want to develop problem solving skills, let's lock in. Now, solve. X squared minus 10x plus 25 is equal to 0. Now, this is a quadratic. How do I know it's a quadratic? Because the biggest exponent we see is a 2. Right? We don't see an exponent here. There's an invisible 1, right? With this x, invisible 1. If there's ever no exponent written, it's understood. What's understood don't need to be said. What's understood don't need to be written, right? That's x to the first power, right? But that's not the biggest exponent. The biggest exponent is this 2 right here. X squared minus 10x plus 25 is equal to 0. This is a quadratic equation, okay? Now, typically when we see quadratics, we could either use the quadratic formula, we could use the completing the square method, we could solve by factoring. Sometimes if we have a quadratic and a constant only, no linear term like this, we can use the square root property. But we can't use the square root property because we got a linear term, right? I'm not going to use the completing the square method. I'm also not going to use the quadratic formula. I'm going to factor this, right? It is key. If you are in Algebra 1, you should know how to factor. You must know how to factor any quadratic that you see, all right? You should know how to factor quadratic trinomials, quadratic, if it's a binomial and it's, a difference of 2 squares, you need to know, there are like 5 to 6 methods of factoring that you should be fully aware of and proficient at any given moment. You got to make sure you know how to factor. You got to know how to factor expressions. You will always use that in any subsequent math course you take. All right. X squared minus 10x plus 25. There's a few ways to do this. Right? This is a perfect trinomial square, right? Because, or is it? It is. It is. Because the square root of this number, right? If you multiply that by 2, that's equal to the middle term. The square root of this number, if you ever see a quadratic trinomial, this is what we call a special case. Special case, right? If you got a quadratic trinomial, 1, 2, 3, trinomial, a tricycle got 3 wheels, a trinomial got 3 terms. 1, 2, 3. Terms are separated by pluses and minus signs. Pluses and minus signs. So somebody might be looking at this like, oh, don't this got 4 terms? Because isn't negative 10 and x, isn't that 2 terms? Technically, yeah, but put together, they represent, they represent 1 term. Negative 10x, that's 1 term. X squared is 1 term. Negative 10x is 1 term. 25 is 1 term. All right. If you ever see a quadratic trinomial and the last term, the constant term, is a perfect square, And what's a perfect square? Perfect square is a number that has a factor that can be multiplied by itself, and it equals that. So 25 is a perfect square because 5, which is a whole number, can multiply by 5 and equal 25. That's why. 24 is not a perfect square because even though you can do 6 times 4 to get 24, you can do 8 times 3 to get 24. You can do 12 times 2 to get 24. You can do 24 times 1 to get 24. There's no whole number that you can multiply by itself to equal 24. There's a decimal you can multiply by itself to equal 24, but no whole number. So therefore, 24 is not a perfect square. 25 is a perfect square because I can do 5 times 5, 5 times itself. That equals 25. That's why 25 is perfect. 9 is perfect. 100 is perfect. 81 is perfect. 49 is perfect. 64 is perfect. 121 is perfect. 625 is perfect. 1 is perfect. 4 is perfect. 16 is perfect. And the list goes on. But anyway, if you have a last term that's a perfect square, when you take the square root of that, which is 5, if you double it, if you double that square root, if it equals the coefficient of the middle term, coefficient is the number part next to the variable. That's what a coefficient is. Make sure you know the math language. Coefficient. Make sure you know the math language. If you double it, if it either equals the middle term or the opposite of it, because 5 times 2 don't equal negative 10, but 5 times 2 equals positive 10, which is the opposite of negative 10, then that means that this is a perfect trinomial square. Some people call it a perfect square trinomial. Sometimes I vacillate. Sometimes I might call it a perfect square trinomial. Sometimes I might call it a perfect trinomial square. So the way you write the answer is like this. One set of parentheses. You take the square root of the first term, x squared, which is going to be x. Put it right there. Square root of the last term, which is 25. Last term 25, square root is 5. Put the 5 right here. You take the sign of the middle term, not the sign of the last term, not the sign of the first term, sign of the middle term, throw it right there. And then you take an exponent 2, take this exponent 2, think of that. Think of it as taking this one and just put it outside. That's an equivalent way to write that. X minus 5 to the second power. X minus 5 to the second power. Now, you only do this you only follow this method or this process when you're dealing with a perfect square trinomial. Now, how do you know if it's a perfect square trinomial? If it's a trinomial, 1, 2, 3, and the last term is a perfect square, right? And its square root, right? And doubled is going to equal either the middle term coefficient or the opposite of it. If it satisfies all the criteria, then you can write it like this. You can rewrite it or factor it like this. Take the square root of the first term, throw that right there. Take the square root of the last term, throw that right there. Where's this minus sign come from? The sign of the middle term. If it was a plus sign, we would put a plus sign here. Excuse me. What goes outside? The exponent 2. So you can either write it, this is like a condensed way to write it, or you can write x minus 5 times x minus 5, which is equal to 0, right? This is the same factor. This is a factor. This is a factor. This is a factor. This is a factor. This trinomial has been factored into 2 binomials, 2 linear binomials. It was quadratic, now it's linear. Quadratic, now it's linear. Why is it linear? Because the biggest exponent is a 1 now. X means x to the first power. X means x to the first power. This was x to the second power, but we broke it down into simpler expressions. So now what you do is, now we want to solve for x. So we take one of the factors and we do x minus 5 is equal to 0. And then we solve for x. How do you isolate x by itself? You get rid of this negative 5. Do plus 5 on the left side. Do plus 5 on the right side. It's like our ancestors in ancient Kemet. Mayat, balance. Whatever I do on the left side, I also do on the right side. Cross that out. Bring the x down. What's 0 plus 5? 5. X equals 5. Do I need to do x minus 5 equals 0 again for this factor? No, I don't. Think about it. It's going to be the same answer. Why would you do it again? Come on, bro. Don't do it again. X equals 5. So the solution is x equals 5. That's going to be the solution. Solution is x equals 5. Go back and check your work. 5 times 5 is 25. Negative 10 times 5 is negative 50. Plus 25. 25 minus 50 is negative 25. Negative 25 plus 25 is 0. That's it. That's how you factor a perfect trinomial square. And then you write it out. Take each factor. Solve for x. All right. Make sure you subscribe to the channel. Drop a comment down below if you didn't understand something. Like the video, share with somebody else. I'll see you next time. Peace.